Chapter 3, Lesson 5. This is the second round of notes, so that one note section wasn't, 45 minutes. And this is how we would do it in class too. We would do one round, one homework. Here's round 2 with more examples. These are the Algebra 2 level examples. So I'll be doing a little bit more in-depth denominators and perhaps more quadratics that I'm solving. We kind of got started a little bit with the other ones, but I'm still on these 3-5 notes. So come back to these notes and come to example H. Okay, so I'll give you a sec to find that correct thing. So 3-5 notes, and we're on like the, third page in, fourth page in, and it's example H. So first we find the LCD. So look at all those denominators, right? LCD. All right, so let's see. We got an x squared. So that means since x squared is the highest exponent present for my x, an x squared has to be part of my LCD. Now, we've got this 2 in front of these two pieces. So if you do 2x squared as your LCD, you'll cover both of those pieces in your cancellation potentials. Now, look at that LCD. We've got to know what x cannot be equal to. And if your LCD is one multiplied piece with no plus or minus signs between it, it's just that x cannot equal 0, and that's it. So now what you do is take the LCD and multiply it by every piece. Now, there'll be enough places where cancellations happen that there's no need to panic, right? But you do want to take this time to do this rewriting, okay? I promise you want to do that because it cancels differently in different spots, and you don't want to be kind of stuck with the wrong cancellation because you tried to do one big right instead of rewriting every single piece times your LCD. This time really is worth it for getting the right leftover to distribute in your numerator, okay? Because again, this is at the Algebra 2 level. You want to make sure you've got the right stuff that's distributing in your numerator. So here, this one's going to be nice because the x squareds just completely cancel. So all I'm distributing in this numerator is the 2. So 2 times x squared and 2 times negative x and 2 times negative 6. So I get 2x squared minus 2x minus 12. That piece is done. Now, this negative is going to come into play, so be careful. First, let's just look. The 2's are going to cancel out. Okay. X squared divided by x. Well, the squared cancels and the x is gone here, but this x stays. And what is that x? It's negative. So both of these things are multiplied by a negative x. There we go. I don't know why that froze with my hand in the way. So negative x times 2x is negative 2x squared. And negative x times 12 is negative 12x. So you want to be careful that this negative distributes and this x distributes. So it's a negative x that's distributing. Right here, I'll circle this guy. He's the guy that's distributing. Done there, equal sign. The 2's cancel. The x cancels out the squared part, and now you distribute here. It's a positive x, so positive x times x is x squared. Positive x times negative 6, negative 6x. So now, let's just combine like terms on the same side of the equal sign first before we move on, okay? So if you look, this is actually kind of nice. 2x squared minus 2x squared, well, those cancel out. Those are gone. Now you've got on the same side of the equal sign, negative 2x and negative 12x. Those add up to negative 14x. And then this guy doesn't have a partner, negative 12, right? No more numbers on that side of the equal sign, gets moved down. And then if you look, this x squared over here, well, that stays. So that's actually what we're going to move these two pieces to go over there to. okay? So it looked more complicated than it ended up being by the time we combined like terms on the same side of the equal sign. So add this 14x, add it right here till it's like term, and then add this 12 and add it back here because there's no other numbers on that side of the equal sign. You get 0 equals x squared plus 8x plus 12. What are the factors of 12 that add to give me 8? 4 and 3 is 7, so that's out. About 6 and 2. 6 plus 2 is 8. And they're both positive because that's a positive 8 in the middle. And now we t-chart. Set them each equals 0. X plus 6 equals 0. So x has to be negative 6. And x plus 2 equals 0. So x has to be negative 2. Let's just double check up there. What did I say at the beginning x was not allowed to be? X is not allowed to be 0. So guess what? I get to keep them both. Look at that. Do that little check to make sure I've checked what x wasn't allowed to be, right? It's good algebra 2 one. Good algebra 2 level 1. Much cleaner than it looked in the beginning, right? Because of combining those like terms, it really did take care of some of those terms, right? Combining like terms on the same side of the equal sign really did help me out there. Okay, well, you know that we're going to do I and J, so let's just go, right? Might as well just go. Now, we did the LCD together for earlier, and we did what x could not be, but let's just go over it again. So if I see these polynomials, these binomials in my denominator, really just make each one part of the LCD, and then that way, I'm shedding as I talk, then that way, you've got all the pieces that potentially are in a denominator taken care of. So what you want to do here is your LCD is actually x plus 3 as one piece, and the other piece here is the x minus 2. So those are your two pieces of LCD. Now, you kind of treat your LCD like it's a little mini T-chart question, right? What can't x be here? Well, what if I plugged in a negative 3 there? Okay, that would make a 0, and that's not something I can have as an answer. And here, what if I put a 2 there? Well, that would give me a 0, and then that's not what I can have as an answer because those things are in denominators, right? So you can just look to the LCD to figure out what x isn't allowed to be. Now that you've got your LCD, so this part takes up space and time, but it's worth it because we can literally cancel what doesn't get to be there. Okay, so take this time, x plus 3 times x minus 2. This is my full LCD, and it's being multiplied by 1 over x plus 3. Okay, now let's do it again. It's full LCD. So x plus 3 times x minus 2. And it's all getting multiplied by x plus 4 over x minus 2. Okay, and then one more time on the other side of the equal sign, x plus 3, and I know I'm invading J's territory, but I'll still have room for J, don't worry, times 6 over x minus 2. Okay, there you go. J, you're just, lost a little bit of your territory. Sorry about that, bud. It's worth it. It's worth it because x plus 3 cancels out completely. So now this whole thing multiplies by this whole numerator. You're in luck. Anything times 1 is itself. Bring it down. You're done with that piece. Move to the next piece. This whole thing cancels. But what it leaves, and I'll write it out. Getting interrupted.
For the afternoon announcement. Bus 1, students riding bus 1 will ride 13 today. Students riding bus 3 will ride bus 11. Students riding bus 4 will ride bus number 6. And students riding bus 7 will ride bus
I have a distinct feeling that that's going to be the announcement every day anyway, so I might as well have it recorded and part of this. This entire binomial multiplies by this entire binomial. So I rewrote it down here because now you can plainly see I'm going to have to FOIL that. And that's okay. We'll FOIL it. It'll look good because, you know, foiling is awesome. Over here. Totally canceled out. Now, and again, I would rewrite this, but you can see that the 6 is just going to multiply by both of these pieces. So how about I just bring it down to the next line? That's one less thing I have to worry about on this line where now I have to FOIL. And so again, just FOIL this, right? First outer, inner, last. X times x is x squared. X times 4 is plus 4x. X times 3 is plus 3x. 3 times 4 is plus 12. Bring down your equal sign. Your 6x plus 18 is on this side. And don't forget about up here you had x minus 2. On the same side of the equal sign, just combine all your like terms. So all the x terms, okay, go together. X plus 4x is 5x, plus 3 more is 8x. 2, negative 2. So 12 minus 2 is positive 10. And then, of course, nothing was like the x squared, so that's going to go in the front. And this was a positive 8x, so I'm putting a plus there. Now bring down your equal sign. You got 6x plus 18 over here. Everything goes to be with the positive x squared. So if x squared is already positive, move the other stuff to be with it. So subtract 6x, we'll line up the like terms. That's a 2x, right? Subtract 18, we'll line up like terms. That's a minus 8. And, oh, there you go. What are the factors of 8 that will subtract to give me 2? And that would be 4 and 2. But you have to watch your signs because the middle is positive. That means the bigger factor has to have the same sign as the middle. So it's a positive 4 and it's a negative 2. And now T-chart. Okay, so let's see. What did we get? We got x equals 2 and x equals negative 4. Now, your first instance of this. Okay, I'm going to scooch this up. Your first instance of rejection. Why do I say that? What was x not allowed to be? Negative 3 or positive 2. And guess what we had? Yeah, reject. There you go. But I get to keep this one. Hello, negative 4. You are the only answer we keep. One more. Bell's about to ring, so you're going to see it in a sec. Or hear it in a sec, I should say. Okay. All right, when I've got stuff like this, x squared minus 3x, I factor that. I see a GCF. I get it out front. So I turn it into its two pieces, okay? And I say, okay, that's the biggest denominator I've got. Can these multiply by something to become that denominator? Yes. So if I multiplied each of these by x minus 3 as part of this, then I would have all the same denominator. So this whole thing, that is my LCD. So I'm just going to keep it as its two factored pieces. Told you, Bell. Now, what can't x be allowed to be? Well, it can't be 0, because if I put a 0 right there, we'd get a 0 in a denominator. Not cool. And it can't be 3, because 3 minus 3 is 0. Those are the things x is not allowed to be as answers. Now, I take this whole LCD and multiply it by every piece of the equation. Okay, there's 1. Now, x times x minus 3. Totally worth it. I know I'm going to have to squeeze. Oh, I'm going to squeeze. Totally worth it. I promise. 4x plus 2. X squared minus 3x is the bottom. And of course, you know that this is multiplied by x and x minus 3. Oh, stupid I took up space from J. Okay, That's okay. We still know what's being multiplied. Here, total cancellation of that piece. But now what that means is these two binomials are going to multiply together. So just bring them down to the next line. We'll FOIL them in a sec. Total cancellation of these x's. That means these binomials come down to the next line. That's okay. We'll FOIL them in a sec. Here, you already know that this denominator actually factors to become the LCD we use. So this entire denominator, oops, drew on my sheet, cancels with that entire denominator. So what you need to be careful of is this negative in front and distribute that. You get a negative 4x and a negative 2 that come down to the next line. This is actually, so I'm going to FOIL these, but you're going to notice that this is not a quadratic that you have to solve, and you'll see that when I FOIL, okay? You are going to get x squareds in the initial FOILings. X squared plus 2x minus 3x minus 6 equals, okay, FOIL again. 4 multiplications, x squared minus 1x minus 3x minus 3. Bring down your minus 4x, bring down your minus 2. It's combined like terms. On the same side of the equal sign, these two add up to a negative x. So x squared minus x minus 6 equals. These combine with this minus 4x. So you get minus 4x minus 4. Okay, bring down your x squared. Sorry. Minus 4x, that's negative 8x in the middle. And then negative 3 minus 2, that's minus 5 at the end. But look, you got a positive x squared on both sides, which means that if I try to move this x squared over to be with that x squared, they cancel on both sides. So actually, you don't have a quadratic at all. Those x squareds are gone. Now you're just dealing with a singular x term. So, okay, that's fine. Let me actually add 8x over here, and I get 7x. And then let's add 6 over here, and I get 1. So actually, when I divide all this out, I get x equals 1/7. And I just leave it as 1/7 because otherwise 1 divided by 7 is a non-repeating, non-terminating decimal. This is a rational number still. And it works because it's not 0 and it's not 3. It's very prevalent to get fractions. I know I hadn't gotten any fractions quite yet, but it's very prevalent to get fractions in these problems. Okay? Now that's a good number of problems. If you need me to do more, please, please, please ask me during class, during office hours. I'm more than happy to help you guys. Really, I'm more than happy to do more of these problems. Just ask. Okay? Okay. So this was chapter 3, lesson 5, round 2. Please make sure you ask questions. Rewrite the LCD times each piece. I'm going to go over all 5 lessons on the review. So I'm going to do a separate video for that, even though I don't normally do that. But we've had lots of different equation solving, and I want you to be proficient in all of those equation solvings, right? We're starting to add that Algebra 2 level to our work, okay? So just let me know. I am so happy to do this stuff. You know I love doing this math, okay? It's so much fun. All right. I shall be seeing you, algebra. Math analysis. That's your class. Goodbye, math analyzers. I'll be seeing you soon.